This conference will now be recorded.
Okay, so we are going to start about RAID. What is RAID and the types of RAID and how to implement RAID 1 in Linux. So this is a normal hard disk, and in this hard disk data has been written serially, and then let's say if you have a bad block which may the beep noise is this what you're talking about?
Yes, sir.
Is it better or still the same? No,
Fine, sir. Fine.
okay. Voice is still there. I'm at the same place. I've just changed the microphone. Previously, I was using laptop's microphone. Now I'm using headphones because headphones is better for noise cancellation. Actually, daily I used to use that, but I don't know how I missed today. Yep. So in hard disk, we may or may not have a bad blocks. Bad blocks means like that area is not accessible. That blocks are not accessible. So that is required to be recovered either from the operating system or maybe by recovering the hard disk itself. So it may happen, may not happen. So at that point of time, whatever the data is written in that particular block, you're gonna miss. You're gonna miss that particular data, whatever is written. And in case, let's say if your hard disk itself got damaged, then in that case, you are done with your data. So for recovering from such situation, there is a solution came called RAID. Its abbreviation is redundant array of independent disk. So it's like we will have independent disk can be set up like this. This is in one example. I can say that this is disk 1, this is disk 2, and we'll write down the data in a manner that I will be able to recover in some point of time. So most of the time, what you will see in industry is like RAID 1, which is this one actually, the model which is I'm showing. So in this point of time, data whatever comes from the operating system, data will be get written here and data will be get written here as well. So the same data will go at both the places. Let's say if you have three disks on the top of three disks you have created RAID. So in this settings, same data will get written on the three three disks actually. So if any disk you loses or any disk or any data is losing, you uh, any hardware is losing here, any one of these, you will be able to recover either from another device or this device. If you're losing this, let's say, then you will be able to recover this data from this device or this device. And there are several features this RAID 1 supports. Like let's say if you have this hard disk is gone, so it automatically sets it offline. Data will be get written here in this two disk. And let's say if you have a spare disk, let's say if you have added one more extra disk and you wish to add, sorry, you have added one extra disk in your hard disk and you wish to add this extra disk as a part of this RAID, then you can do the settings, and whatever the data is here, it's automatically get written. Whatever the pre-written data here will get written automatically here as well. And after writing all the data, whatever data will be getting written next time is going to get written everywhere. So it's like it automatically rebuilds. The copying existing data from this disk to this disk is called rebuilding. So it automatically rebuilds from its own location, from the existing data to the new hard disk. So now at this point, these three are part of this RAID. This one, and this one. So this is RAID 1 actually. And
Sir, you are in mute, right?
yes, I went on mute. Not sure when this problem will be get resolved from the server or from somewhere else. So RAID 0 actually it's accessing the data. We in this RAID 0 we'll have two disks and we'll strip down the data. Let's say whatever the data is going to come, what are the data is going to come from here. What are the data is going to come from here? We are going to strip it down into uh, two chunks of data and we are going to separately write it down here, and then we will write one portion here. Let's say we have a chunk of data which is getting divided into some number of bytes. Let's say A1 byte, A2 byte, A3 and A4. So A1 will get written here, A2 will get written here, A3 will get written here, A4 will get written here, A5, A6. And there will not be any parity bit. Parity bit are like the bits which tells is there any error or not in the data at the time of recovery. So for sure, if you're going to lose one disk, you are going to lose the data here. The RAID 0 is not going to solve your problem. of redundancy. So this RAID 0 has been meant mainly for faster accessing of the data. So like whatever the data could have been accessed from disk 1, it could be accessed in half of the time from if it's divided into two disks. So that's what the purpose of RAID 0 actually mainly. So this is RAID 0. We have seen RAID 1, and further we will have RAID 2. So in RAID 2, we copy the data here. Along with that, we maintain the parity bits in separate disk as well, so that whenever we lose the data, we can get the data, or we can check, we can uh, recover the data from the parity bits. So those we save in separate disk itself. That's actually RAID 2. And in RAID 3, what happens is we save the parity bits in only one separate disk. RAID 3, we save the parity bits in only one separate disk, and we'll have two disks. Okay, it looks to be like very much clumsy. Okay, let me find out a web page for that, and I will send out a link for that, so that where it tells about in a good graphical representation. So just give me a minute. RAID levels wiki I have done, and here is the RAID levels. You should be able to see that. So RAID 0, this is the diagram I have explained. A1 most of the organization it has been used. RAID 1. RAID 2, you can see that data has been divided A1, A2, A3, A4, and the same parity bit has been divided in the similar kind of disk. So it's like 4 disk or 2 disk, whether the data will be get divided evenly, and the parity bits also will be get divided evenly. So here we can see that data is here, and the data is distributed in different disks, and the parity bits is distributed only in one disk, kept in one disk. So that's a type of RAID 3. RAID 4 is we have the data in RAID 4, data will be get broken and will get written parallelly. Let's say we have a data called uh, let me give an example here itself. So let's say we have data of this much length. It can be of more length as well. So those data can be divided in equal part. Let's say three parts. I'm dividing 1 2 3. So here three part is going to be like this. So this data will be get written in first disk, this data will written into second disk, this data will written in third disk. Similarly, here also data. First data will be get written in this disk, second data this disk, third data this disk. So it's we are dividing based on the total number of size. Sorry, we are dividing the data based on the number of divisions, not total number of size here. So we want three division. Let's say you have 1 MB of data. So 1 MB of data you are required to divide in three parts, and then first the 300 1 MB of data. So first the 300 KB will be get written to one disk. Second 300 KB will be get written to another disk. Maybe 330 KB, 330 KB, 330 KB. All the data will be get divided parallelly and then get written. Let's say if you have 1 GB of data, then in that case you will have to divide 1 GB in three parts. 333 MB of data will be written here, remaining here, remaining here. So and the parity bit is going to get written here. That's another part of another type of RAID, another type of storing the data. So it's nothing but storing the data actually. How you are going to store the data. That's it. So RAID 5 is in this we will be storing the parity bits in some of the disk itself. We will be distributing like A1, A2, A3 and B1, B2, B3, and then we'll be distributing the parity bits in the same disk itself. So here is RAID 6. In RAID 6 A1, A2, A3 and then parity bits for that A. So it is like dividing the data A1, B1, C1, A2, B2, C2, A2, A3, B3, C3 and then checking out the parity bits of these parallel data and storing it somewhere. So it's like that. So nothing much. I mean, we are not going to implement uh, many of those. We I haven't seen the nested. Actually, there can be a nested RAID as well, where you'll be able to find out that RAID 0 plus RAID 1, RAID 1 plus RAID 2, something like that. So where it talks about uh, like you have a RAID 1. RAID 1 means this is RAID 1 copying data at same places, and then a RAID, and this is RAID 0. RAID 0, this is RAID 1, this is RAID 1. So it's like RAID 0 means whatever data is going to be get divided in two parts, let's say. So one part of data will come here. So in this case, whatever data is going to be get written here is going to be get written.
Not getting your voice, sir.
Yep, sorry. Thanks for that. So here we are going to we are going to achieve the faster rate, and in that we are going to achieve the redundancy of our data as well. So we are not going to lose the data. So in this case, you can see that whatever the bits are going to come here in RAID 0, what we have seen that bits are. Yep. So in normal RAID, what I mean RAID 0, what we have seen now just few minutes back is data is going to be divided into parts, and one part is going to be get written, another is going to be get written, then next is going to be get written here, and the next is going to be get written another side. So let's say one side is going to be get written. Let's draw the diagram of data itself. Let's say we have A1, B1, C1, D1, E1, F1, like the data we are having. So we are going to write down A1 here, B1 here, sorry, B1 here. So A1 will come here, this side, and in this side we'll have two disks. So whatever data is going to get written here, A1 is going to get written here, A1 will get written here as well. B1 is going to get written here, so B1 is going to get written here because this is configured as RAID 1. This is configured at RAID 1, and at the top of RAID 1 we are configuring RAID 0. So A1, B1 is written. C1, D1. Let's say C1 is, we are copying C1. C1 is going to get copied here. D1 is going to get copied here. C1 is going to get written here. Then C1 is going to get written here. Data is getting copied in both the places, same data because it's on RAID 1. And D1 here, D1 here. So this is actually the nested RAID. It's called nested RAID. And this, in this configuration, you are going to achieve your speed as well, and you are going to achieve your redundancy also. So some places you may see that they have using like this. So let's come back to what we are going to use, okay, and see the practical of that. So we are going to use RAID 1. So you may be asked what are all different RAID levels in interview and explain about them. So you need to know about RAID 0, RAID 1, RAID 2, RAID 3, RAID 4, RAID 5, and RAID 6. That's it. And if somebody asks what is nested RAID, you need to tell. Okay, here you can see that it's mentioned, but nowhere diagram is given. Combination of two or more standard RAID levels. There may be also known as RAID 0 plus 1, RAID 0 or RAID 01, RAID 0 plus 3 or RAID 03, RAID 10. I have explained RAID 01. There can be RAID 10 also. Okay, so you can see that RAID 5 plus 0 or 50, like 6, RAID 60. So similar, something like that we can have. Mm, Hmm. Now is it clear?
Yes, sir. Yes, sir.
Yes, sir.
Yep. Sorry guys for the noise, background noise and interruptions because I'm not at my original place. I just came to a different place where I am going to be for a week mostly. So sometimes there may be interruptions. So but let me know if it's going beyond the level. I mean, if you know guys are not able to hear, let me know so that I can do some workout because things are getting recorded also. So if things are not clear now, it will not be clear if you're going to listen later also. So this is about RAID actually. So let's talk. So yeah, I was talking about RAID 1. So RAID 1 we are going to have. So this is our virtual machine. Okay. In this virtual machine we are having 8 GB of volume. So we are going to use that one, 8 GB of volume. So what extra we are required to do is we are required to format a drive and add it into our virtual box here. This is virtual box. We need to add one more drive here so that we can access these one disk and two disk, or we can make RAID1 out of these two disks. You can make three disk also. It's not bound to two disk only. You can make four disk also. That's not a problem. You can make a number of disks. I'm not sure what is the maximum number RAID1 is going to be get supported, but this is what it is. And in this RAID1, we will install a software called MDADM. That software provides a layer. That software provides a layer. So whenever we have a disk, I have shown you in our previous lectures, we might have seen that this disk will be visible as /dev /sda, correct? Everybody knows that. And if we have server partition, it will get visible as /sda1, sda2, sda3. So let's assume that this is not sda1, sda, this is sdb. Let's assume that this is sdb and this is sdc /dev /sdc. So both disk will be visible. When you create RAID, both disk will be vanished. This disk will not be visible to you. What will be visible? MDADM is going to create one extra layer on the top of these two disks, and it's going to add one extra disk here. It's going to populate one extra disk, which is called maybe /dev /md. I'm not sure what is the name. Let's say mdxxxx. Okay. Yep. So this will be visible. MDXX. Let's say that's a operating system, or MD Adam is giving this name. So this will be visible to you. So whatever data you are going to write, you will be writing your data into /dev /mdxxxx. This will be the location where you will be writing the data. But now when you know, I mean, everybody knows so far that how to write the data here. This is a device list, and this is a device link, a device file. We need to mount this device in some particular folder, and after that we can copy the data, paste the data. Then after some point of time we need to unmount this as well, or do some process if you want to remove this disk. So what will happen when you write the data? When you write the data, MD Adam will layer will take care of it, copying the same data to both the places. If you're trying to read the data, like, So let's say if you're going to read the data, what will happen is MDM will get the data or fetch the data from any of the disk and it will give you. Let's say if MDM is setting the primary disk to disk, so it will get data from here. And there are several operations in RAID. What is that? I've told one rebuild. So for rebuilding, you are required to, let's say you have created a RAID out of two disks. So in these two disks, you are removing this one disk. Then this RAID 1 will be called as degraded RAID. Degraded. So this RAID 1 is got degraded. Okay. So after this, what is the process? You are required to add a spare disk here. We call the disk as a spare disk. Using software, you are required to add this disk as part of this RAID, whatever the RAID we have created previously. And as soon as it gets added as a part of this RAID and in a spare disk, it will automatically start copying the data from this disk to disk. Let's say it was having existing 100 GB of data. So it has to write down 100 GB of data here. So that is called rebuilding process. There is one more terminology that is called pass-through disk. Okay, yeah, I got it. What is called pass-through? Let's say you're having an operating system. This is the layer of operating system, and this is the layer of MDM. So this disk is part of RAID. This disk is part of RAID. This disk was part of RAID. Now you have another disk here, which is not part of RAID and which is getting directly mounted to operating system, which you think that's named as /dev/sde sdb sdc sdd. You can say that sdd. This is sdd. So this is getting mounted as RAID, and you can write down the data parallel to this. If you want to write, if you don't want to write down data on RAID, you can write down the data on this. So this disk is called as pass-through disk. The disk is called as pass-through disk. So we'll have pass-through disk initially. We'll, with the help of MDM, we are going to create a RAID, and after creating RAID, we'll try to copy the data. After copying the data, we'll fail one disk, or we'll remove one disk, and we'll add another spare disk. We'll remove one disk, and we'll add another spare disk. After adding another spare disk, it starts rebuilding. So this is what the process of RAID 1 actually. Okay, so we'll try to achieve this, and let's see how it's done. Anybody has any doubt so far in this?
No,
Okay,
sir.
let's proceed. Let's proceed further. If no doubt, then so we are having CentOS 1. So let's see how many disks we are having. This one was having 2 GB. Okay, let's see 2 GB itself. Rather than 8 GB, we'll concentrate on 2 GB. We are not going to touch this CentOS 1. The reason for
So not getting your voice.
Yep. So we have this disk. We have this disk CentOS1.vdi, and where we'll not touch this. The reason for that is we are having operating system in this disk itself, and we don't have any partition here actually. Okay, so we are not going to touch this. So this we will. So this one we will we will use this CentOS1_1.vdi as a RAID partition, one RAID partition, and another RAID partition. Let's add it here. Okay, let me explain some concept here. Where is that? You will have a motherboard, and that motherboard you will have a place where you connect your hard disk. This is a slot where you connect your hard disk. Okay. Anybody has seen server, rack server? Anybody? How the rack server looks like? Hmm. In movies, you might have seen that this kind of infrastructure. Okay. So this is called a rack server actually. You can see that this is rack server. Okay, let me zoom this, the front view. So this is here you will have two machines. You can see that. Come on, man. That was the only one image. Okay, so this is full rack actually. It's the pillar. In that you can see that this is two racks, and in that rack this is one server, another one is another server. Let's go to the diagram here. So this is the front diagram. From front it will look like this, and one server will look like this. This is the front diagram. Yeah, this looks more clear. So this is a front diagram of your server. So this is the one server. Here we will have a handle actually. You will have a handle at one side, maybe sometime two, both the sides. So you are going to pull this outside. You will, when you pull this outside, this whole server is going to come outside. So this is also a server. So it's like one rack will have n number of servers. You can count 1, 2, 3, 4, 5, 6, 7, 8, maybe 19 also. So you can have 10 servers running. It's not desktop actually, it's servers. So which any of the production or any company uses. Let's say if you're calling as Google, Amazon, all server are built up like this. Everywhere it's all the clouds also used to be get built up on the top of these rack servers only. Yeah, you can see that this person is working. So here you'll have several servers, and on the top of several servers, let's say I'm taking an example of one server. This is one server. So in this, you can see that at this point of time, you don't have any holder here, or you don't have any clip here. So you are going to hold this particular portion, and you are going to pull up means like pull towards you. So this whole server will come out because it's on the rack. So that's what the construction has been made, so that it can come out and it can go inside easily. This whole server itself I'm talking about. So in this, these slots you are able to see. These are all actually disk. So 9 disks parallelly you can connect it. And when you open this server, you will have PCI slots also. In that you can separately.
You are in mute, sir.
Yep, it's unmuted. I think. Yeah, it's unmuted now. So when you take out the rack server, it will look like this. Image is very small actually. So yeah, you need to take out like this back rack, pull, and then you can push it inside. Okay, you can push it inside, so it goes inside. So how it looks from the back? Yeah, from the back it looks like this. Several LAN connection will be there. Two LAN connection will always be there. One to manage your network, another to manage your this BIOS and all everything of this server itself. You will have two servers, two LAN cards, and this is a VGA card through which this is also comes through LAN actually. So this is a VGA card. So VGA will also have a separate LAN connection. So all the things, and this is a kind of power cable. So from backside, your server will look like that, and there will be several bunch of cables which goes, and there will be separate set of cooling. You will see that the cooling of the normal this server rack room where it has been kept, it's very low temperature. Maybe it might be 15 or 20 degree. It has to maintain because that's what the industry called. And some medical devices, if you are seeing that server is meant for medical use or medical purpose, then temperature used to be more lower, maybe 10. So that's what the case is. Okay, so here you can see that this is one disk, this is another disk, disk 1, disk 2. If you push this button, here is a button. If you push this button, this disk will come out. If you push this button, this disk will come out. So this is how we take one disk out and push to get disk inside. So this is the setting of disk. I mean, you can insert one disk, you can take out one disk, another disk, and there are several PCI slots also inside on the motherboard. You can plug your PCI hard disk, which supports PCI. Okay, so that is also there. So it's like what I was talking about. Let's say you have created out of these two RAID, and one got damaged, one is not accessible, or one disk has got failed. You just push the button, take it this out, and you can insert another disk at this point of time, and then you can rebuild your, or you can mark that spare and you can rebuild. So why I showed this diagram, because you may not have visualization that how I'm saying that another disk will get added. Here we are adding in a virtual disk, so you can say that okay, fine, virtual it's possible, but how it's possible physically? In laptop you're not going to open your laptop, you're not going to add anything in that, but that is possible in servers. All these things has been made for servers. So those whatever you have seen, it's those are all rack server. It has been used by all every company, whether it's a Google, Intel, Amazon, Flipkart, anybody uses that same rack servers. May purchased by some vendor or another vendor, and then uh, they mount or they keep their data on those servers. So most of the time, you guys are going to work on those servers only. Actually, that's what your work is. You're not you will. I don't see that you guys are going to work on any of the Linux desktop actually. So what you will have is you will have this kind of rack servers. You will have this kind of rack servers. On the top of that rack servers, you might go install a Red Hat or maybe CentOS or something like that, on the top of that, and then you get the IP address and you'll come out of the server room, and through IP address you will access that system, and whatever configuration you are required to do, you will do that. Yeah, this is also taking the system out and then taking the system in. Okay, this is what it is actually. So yep, so you will take this disk out and you will take another disk in place of this server, this not server, sorry, in place of this hard disk, and then you can configure your RAID again, so that you may not lose the data and you may not lose the server continuity. So your operating system will still run, your data will still intact. If some application wanted, let's say you have created RAID out of two disks, this disk and this disk, this got damaged. So whenever any application wanted to access the data, it will access from here. It will not access from here because this disk is offline. Offline why? Because it is disk is having bad block or inaccessible. So when you add this disk as a part of RAID member, then this disk will take part in getting the data access for any application. So I hope this is clear whatever we are saying. So let's move on to the practical part, how this we are going to achieve. So let me add. So as of now, I'm just going to add 2 GB of data, 2 GB of volume. So in server, basically all the hard disk, most of the hard disk comes around 1 TB or maybe more than 1 TB. Okay, so you might be performing all the operations on terabytes, not on GB. Yeah, okay. One more main information I wanted to show and I missed here. So here everywhere we will have a controller actually. Controller, it's a hardware chip which helps in copying the data onto these disks. This is the controller, hardware controller, which where we will connect this our hard disk and which copies the data. So what we are using here, MD Atom. MD Atom actually it's software RAID. MD Atom is software RAID. Okay. So there is something called hardware RAID also. So in software RAID, you know that we'll go to operating system, we'll install MDADM, and then we'll configure the RAID partitions and we'll work on the top of those partitions. So what is called hardware RAID? So you see that I've explained about a little bit about this is a controller, and on the controller only you are going to connect this controller only will have the slots to connect your hard disk, and in those slots you are going to connect your hard disk. So you this all the controllers will connect it somewhere. So you will have an extra chip. We can call it as a hardware RAID chip. You can call or anything or hardware RAID basically. This you can enable or disable from BIOS. This RAID hardware RAID you can enable or disable BIOS from the BIOS. So at hardware level itself, this is going to take care of your RAID. So whenever you write a data, so okay, let's say from BIOS you have created a RAID out of these two disks. Now I'm talking about hardware RAID. Software RAID is done. I'm not going to talk about this as of now. What I'm talking about, what is called hardware RAID. I'm just trying to make you guys visualize that what is called hardware RAID. So in this, okay. So in this hardware RAID, we'll have a controller, and in this controller only, we we will create behind this controller only we will create RAID from the BIOS. You know that what is called RAID1 now. So this controller will create RAID out of two disks, and then this controller will be get mounted in operating system. You can say that /dev/sdb. Operating system will think that this is a separate disk. It has operating system will write data independently on this disk, but the hardware, this controller is going to write internally data in this disk and this disk also. So operating system will never talk about separate two disk. It will visible that this is the only disk which is available for me. Operating system will think, and in this disk only it will write the data. So whatever data will come, this controller will take place where to send, where not to send. How many devices are there behind this? Yep. How many devices are behind this? So this is about hardware RAID. Any doubt here? Any confusion here? Software RAID and hardware RAID. Okay, so we will talk about only software. I mean, we are going to see the practical of only software RAID, not hardware RAID. Okay, but yes, in interview somebody is asking what is hardware RAID, what is software RAID. You should be in a position to say the differences at least. And this hardware RAID you are going to configure through RAID, not through operating system inside. Sorry, through BIOS. Sorry, you are going to configure this hardware RAID through BIOS only, not through the operating system. So inside operating system, you will configure only software RAID, which we will be doing now. So we are selecting the controller. So this is a virtual controller, you can see that. And we are adding one more disk, hard disk. Add, not add, actually create. I don't want 8 GB. 2 GB is enough. Let's create. Let's add this. You can see that actual size is 2 MB. So 2 MB has been left for metadata here, and 2 GB is complete size. Choose this and then press OK. Now we'll start the CentOS 1. We can see that we have ftest-1L, we have SDB and SDC 22 GB. You can see that here. SDB 2 GB without partition, SDC with 2 GB without partition. You can see that. So we are going to use SDB and SDC only. Okay. So there is another application called Parted. Parted, we are going to format an MS-DOS partition of both the disk /dev/sdb mk label MS-DOS. Okay, I will update that fs tab sdb sdc. Okay, fine. Now we'll be able to see that it's showing sdb sdc. We'll format them so that it gets automatically get detected as Linux RAID. So for that, fdisk /dev/db, we have gone inside that, then new partition, primary partition, then 1, then once again enter, then once again enter. I want all the things to be get written. Now we wanted to print, so this is the partition type and the size and all for STB. Now partition table type I wanted to change to Linux RAID. So I wanted to see the hex code of what is called Linux RAID. We can see that Linux RAID auto, here it shows Linux RAID auto. So FD is a hex code for this partition. So I will type it down FD, and then I'll press enter. So change type of partition is, let me go down here. Yep. So for Linux RAID auto detect. Now I will be, previously it was not showing Linux RAID, so you can see that now it is showing Linux RAID auto detect. And then after that we'll type W to write the changes and then done. Same thing we'll do for SDC also. New partition, primary, then done. Then what we need to do is we need to change the toggle it's asking for hex bit is FD. Now we'll print the partition type is Linux RAID detected. Okay, SDC. Now we'll write it down and exit. We have both the disk. Now we'll do fdisk-l. You can see that SDB and SDC. SDB type is Linux RAID. Here you can see that this is also, where is that? Yep, this is SDC, this is SDB. Both are getting detected as Linux RAID. Previously, when we'll talk about Linux LVM, we'll come back to LVM also. You can see that here. Let me show. Yep, you can see that this is Linux partition, SDA1. I'm talking about the 8 GB. We were having one 8 GB volume, correct? So that 8 GB has been divided in two parts. One is SDA1, one is SDA2. So this SDA1, we are looking at 2 GB. So that's created as Linux only partition table, and the partition table is created here is Linux LVM. So we'll talk about what is called LVM and how we can uh, make our partition as LVM and what operations we will do in maybe tomorrow or maybe some other day in another lecture. So currently we are talking about Linux RAID. Linux. Let me see. I have a network connection or not working here. Yeah, it's not. It should be working. So now, okay. Yum install md Adam. Now everybody knows that how to install a software at least. In interview, it can be asked what is the hex value of Linux RAID partition table. You should say FD. If anybody is asking that uh, in which partition table we need to format to convert a hard disk into RAID, so you should say that in Linux RAID auto detect. What is the command you should use? Fdisk and then that particular device number, device name. You should remember all the command actually, whatever we have been performing. They may ask you the complete process. If you're not able to remember, I mean, you have to practice to remember those. If you're not able to remember, you may need to mug up also. Sorry to.
Sir, you are in mute.
Mhm. Thanks for notifying me. Actually, I'm trying to resolve the network issue. Oh, I don't have network connection here itself. What is the problem? Okay. Okay, we're having Google here. Let me change the settings to back to old settings to NAT itself. Hmm. Yep, we have Google. I've used two commands, pkill and kill. Can somebody tell me the difference? What is the difference between pkill and kill?
Kill means kill the process, the active process.
Pkill means
I'm not sure about this.
pkill is also going to do the same thing.
P-kill forcefully kills the command.
Hmm. Hmm. No, that's
Process
not
is
the.
going to kill, so P-kill.
In both the cases, process is going to be get killed. With kill, I'm giving an argument. 9 is going to be the same. Okay, this is an argument for kill. This is an argument for pkill. I'll be back in a minute. Please think. Yep, I'm back. So any so far you might have searched on Google also.
If I want,
Any place? Yeah, tell say it.
if I want to kill the process, can I give kill space process ID? Is it
Hmm.
necessary give kill after hyphen 9?
Okay. Okay. Before that, just reply first of all. First this question. We'll come back to that question. Okay. We'll resolve your doubt. So I was asking that what is the difference between kill and p-kill? Both are going to kill a process. Come on, there are many people.
Yes, sir. So in pkill, we are going to kill the active running process by giving process name and
Hmm.
some other constraint except IDs. Whereas in kill, we are required to give the ID of the particular process.
Hmm. Correct. So what is the other thing? P-kill takes the name of the process actually. Okay. I think it's necessary to give a signal with kill. Okay. Okay. I was telling that we don't have signal.
Sir, I have a question like, can two different processes can have the same name?
I'll take the question. Just wait for a few minutes. Yep. Hmm. So kill is okay. There are two questions. I will come back to both the questions. Okay. So let me finish whatever I was saying. So kill and p-kill. So here, kill and p-kill. There are two commands. Kill is going to send a signal. Kill is going to send a signal to a process. Pkill is going to send a signal to a process. Don't think that kill is going to kill a process. Don't think that pkill is going to kill a process. Okay? It's going to send a signal or process. It's going to send a signal to a particular process. This takes an argument of PID number, process ID number. This takes an argument as a process name, or I can say that application name rather than process name. I will say application name. Process name is not a correct name actually. Application name. What is it? What does it mean? What does it mean by application name? So let's say if you're running top application for looking at the processes. So at that time, I can say that, okay, let me show the example also. So for showing the example, I need to change the network configuration. Let me see if I'm able to ping this machine or not. What was the IP for this machine is IPA 10.02.15. 10.02.15. Yep, I know it will not be pingable. I'm able to ping. So now this is what you will also be going to do. That this is your server running in your a server room actually, whose IP address just now I have changed it to 192.168.56.8, and now you are coming to your laptop and you are opening either Ubuntu, or you have a Windows laptop or desktop, whatever it is. You will in Windows you will open putty application, and there you will try to connect with this server through IP address. Now if you don't have putty, if you are working on, we want to log in as root user, root @ so this is the syntax actually. If you want to do SSH from one server to another server, or from Linux system to another server, what will be the format, what will be the login format? Even anybody can ask that, what is the command through which you can log in? You should say that SSH space username @ the IP address. Uh-oh. Connect to host, protocol not available. Need to do extra efforts. I don't have internet since I have that network locally. So to have an internet, I need to go through NAT. I'm going to install the OpenSSH server. Yep. So, okay, what problem I face? Let me explain here. I'm trying to access that server using SSH. Okay. So SSH is secure shell, which I have explained about. This is an application. So now what it's complaining, SSH cannot, sorry, connect to host this at port 22, protocol not available. So it's like this protocol is not available. Port 22 may not be available. So what I can do next step is nmap-a and that particular IP address 192.168.56.2. Nmap is going to give me the full list of ports which are all open or not available, not open. Okay. This is one method through which you can test whether a particular port is open or not in the server. In this server, I'm talking about this server, particular port is open or not using nmap command or telnet command. That is also an interview question actually. So nmap, when I was running nmap, it says that nmap is not installed. So I have installed the nmap by using this command. Actually, this is Ubuntu. So in Ubuntu, I need to run apt install nmap command. So nmap is installed. Now I will run this command. One IP address. It seems like host is blocking. So I need to give capital PN to scan that. Mhm. So it seems like no ports are open here. It has scanned all of the port, but no ports are open. So port 22 is not open from this server. Let me again make a diagram to make you understand better. This is your server. This is your client machine. Let's say your laptop. From this laptop, you're trying to connect to this server. Obviously, you have to, first of all, you are required to ping this machine. If you are able to ping, it means you are connected from this laptop to this server. If you're not able to ping, there can be some consequences. In firewall lectures, you might have heard that the server is blocking the ICMP packet. So in that case, you can use nmap to get if somebody is blocking the nmap, sorry, somebody is blocking the ICMP packets, then also nmap will detect and tell the host is up or not. You can see that here when I was running first, it said to me that host seems to be down. If it is really up but blocking our ping probes, try -pn. Then I have tried with -pn, the same command I have tried with -pn. And now you will be able to see that it says that one host up is scanned in 0.57 seconds. So it says that host is up. Previously it was showing that host was down. Okay, so we can get to know that our host is up. Fine. So ping tells me that host is up. Now for connecting from this server so for connecting from this server to this server, there is something called port. Here port is not a hardware port. Port is a software port. Whatever application runs on a computer, whatever application. If you think that this application wants to connect to internet, it has to talk through a port. Every application talks through a port. If you are opening any browser also, any data coming from the internet has to go through the port of this system or this system. It has to go through the port. Without port, data cannot go inside and data cannot come outside. So port, you can assume that port is a virtual door for you to enter into this laptop. But how to reach to this laptop is given by the IP address. IP address is the address of this laptop and internet. Through that, you will be able to reach up to this laptop. And after that, if you want to talk, you have to open the door. So for opening the door, you need to look at the port is open or not. So, okay, somebody can ask, okay, fine. You are saying that I need to open a port. So, what is it about when we when we open a browser and we try to access google.com or facebook.com or any website, gmail.com, let's say. So, which port we are talking about? At that time, we are talking about either 443 port or 80 port. Any these two we will be talking about. So let's say if you are mentioning in your website HTTPS, it means you're talking about 443. Automatically 443 will get added by your browser, the port number. And let's say if you're talking about HTTP, so in that time HTTP means port 80 is going to play the role. So whenever you are accessing any local website which is using port 80, so you can say that HTTP, which is using HTTP, you can say that port 80 is going to get utilized to access that particular website. And for HTTPS, port 443 is going to get utilized. Just one second. Yeah, so this is the two port which will be invisible to you, but actually these two ports are getting utilized. So similarly, I am trying to access this PC, this server, not PC, this server on port via SSH. And SSH uses port 22 to connect. So, having said that, here some application has to be running on port 22 so that if I try to connect with this port 22, this application can say that, hey, yes, I am listening on port 22. You can connect with me. So here some application has to run, and from here with the same application or with some application, we'll try to connect with that particular port. And if application acknowledge, we get the access of this. Similarly, you can say that when you try to access a browser either from your phone or your phone from your laptop, your browser is ready to listen on port 80 and port 443. Actually, through browser you can listen on any port by mentioning like this. Here it's HTTPS. Okay, if you want to mention port number, you need to mention colon 433, sorry, 443. So this is the way to give a port number. It's rejecting if we are giving explicitly port number, so it's not taking that request. But if you want to access the port, you can say like HTTP colon double slash that www.google.com colon 443. So that's not slash actually. That's no, once again I have added a slash. So this you can see that HTTP has automatically got converted into HTTPS because that's what the port 443 does. Let me try here also. Let me go to the home page of man7.org. Okay, HTTP colon double slash, sorry, HTTP colon double slash colon 443. Uh-oh.
So you should remove index.html.
Yep, I'm trying that only. Let's see if it's working or not. Your browser sent a request that the server could not understand. Reason you are speaking plain HTTP on SSL enabled server port. But I'm trying to listen on HTTPS. Okay, you can see that this 443 is the port number. If I do mention port number, it's going to listen. Okay, so 443 is a port number. If I'm going to tell this to port 80, it should not listen actually. You can say that secure connection is failed. So I'm trying to access through port 80. Even though I'm giving HTTPS, but I'm trying to access through port 80. Port 80 is non-secure connection, and port 443 is secured connection. So it's allowing me to go through port 443 because port 443 is HTTPS and port 80 is HTTP normal. So it's not allowing me. So understand everybody that what is the significance of port here in accessing any of the network. So this is the significance actually, and here also we are required to open port 22. So how we can check port 22 is open or not? From here I was running nmap command and I was checking port 22. It shows that not open because it did not listed port 22 as open ports. We can do that using telnet also. I will tell you. So okay, let me do the telnet also and see that. So you can don't get confused. This is I'm trying to access from client and this is server. So don't get confused that I'm running nmap from where. I'm running nmap from the terminal. I'm trying to access this terminal. But this is client, this is server. So I'm treating my host machine as a client. So I will try using 10. I will try using telnet also. We have diverted from our main topic actually, since it came on the way. Telnet and then this one and then the port number. This is the format we should give. Telnet space IP address space port number. If it is available, it will say that connected. But you can say that unable to connect to remote host. Protocol not available. Okay, so let me solve this issue. So what I will do is I will install an application over here in this server. That application will run on port, that application will that application will open port 22 and listen on port 22. That application name is OpenSSH-server. So I will install here OpenSSH-server in server. It's installing now. Installation is done. You can see that. Now, after that, I will try to do nmap again. It's not giving me. Okay, let me give the telnet also. Whether I need to open the port. Okay, so I need to add a firewall rule. You might be familiar with this command as of now. Firewall -cmd -zone equals to public hyphen add hyphen service is equal to SSH, and then hyphen hyphen permanent. Already enabled, then why it is doing like this? Reload nmap hyphen a space localhost. So what I'm trying to do here in this server itself, okay, in server I can see that port 22 is open, port 25 is open, and for DNS also there is a port, it seems like, which is also open. No, 22 and 25 seems to be open here in my in my server. And when I'm trying to access this, I'm connecting to the correct IP 192.168.56.2 IPA. Oh, okay. IP addresses is changed. So actually I am accessing the IP address for connecting to the internet. I have changed the network connection, and then IP address has got changed to 10.02.15. So this IP address itself is not existing actually. This IP address was not existing. Before that it was existing. So let me change things. Now host only adapter. I've got the same IP. No, 56.8. Is it the same IP? Let me check. 56.8 is the IP. I'm doing nmap now. It is going to scan all of the ports. So this is how you are supposed to resolve the problem. You need to know what is the problem and then resolve accordingly. So one step by step I have faced the problem and I have resolved it. So you need to go through the video maybe several times to understand what is happening if you have any doubt. It may take some time. So let me open another terminal and try for SSH. Sorry, try for telnet. Telnet comes immediately. Okay, you can see that. Output of this nmap, you can see that port 22 is open. And it has the host key which is available here. I'm not sure why it's showing additional information, but anyways, we have this open port. Okay, so now we will try to do SSH root 58. So now it's asking for us to connect through this. So we'll say yes, I want to connect. Now it will ask for the password. I will give the password. Now we are in. I am inside root of that particular localhost. So I am inside the server. So what I was telling you about, let's run top here. And this is a process top actually. Okay. So if you want to kill this process, which I have run top, there are two ways to do that. You can see that it's still running. Okay, I'm not going to kill this here. I'm going to kill from here. So there are two ways. Either I can get to know the PID of top. I can get to know like this: pxaux grep top PSOX will show the process of its own also. So this PSOX we are running, this is also a process actually. So which ran and exited. So for that process number was 2373, but which is the running process, you will be able to see that this is 2371. How to identify? If we run, you can see that this process number will vary every time as soon as I'm going to run, because it will get created and it will do its work and it will exit the process because work is done. But this is going to be the same because this top is running in this. You can see that it's running in this window. Top is still running. I have not exited this top. Okay, so how to kill this process? There's one way. Okay, there's one way. Kill space hyphen 9. Hyphen 9 is a signal. Actually, kill is not a command to kill always. Kill is a command to send a signal to this particular process top. So what signals you can send? Come here. Where is that? Rack server. Okay, yeah. So you can send all these signals. So where is the sick term signal? Sorry, sick kill. Where is the kill? No, it's illegal. Sick kill is a signal. But the standard it's showing OP1990. Okay, but what is the signal number? It's not showing. Yeah, we got it here. x86 or ARM. We are using this platform is x86 platform. It means Intel processor we are using. So in that for sick kill, we are supposed to send signal 9. Okay. If you want to, there are these many signals are present. These many signals you can perform. So you need to understand that what individual signal does. And if you send that signal, what could be the response of a process? If you send this signal sig stop, it's going to stop. Maybe it's going to sleep, something like that. So you need to send hyphen 19 signal. Okay. Sig up, sig int, maybe int might be to resume the process. So for that, you are required to send a signal number that is 2. If you are using the same thing on maybe alpha or MIPS or parse ISC platform, CPU platform, then you are required to use this different numbers. But for killing a process, you have to use 9. That's what I have been using. Okay. So everybody understood that why I use 9 and what is the value of means what is the significance of 9 here? It's going to kill the process. This command kill is sorry. This command kill is not going to kill the process, but through kill command, I'm going to send this signal hyphen 9, which is going to kill your process. And what kill takes? Kill takes the signal number and process ID. What is the process ID? 2371. We'll see. You can see that now 2371 is not coming. Now go to our server where we were running our top. You can see that it has given K came here and this side and ILLED killed. You can see that it's killed. It will not show that who killed it and how it got killed, but it has received a sick kill signal and it has got killed. And now you can see that your prompt is also back here. Now let me run the top command again. Now we will try to kill it by another method. Okay. So if we look at this now, this time, yeah, 2408 is a process ID for this top, which we have run just now. So now what is another way to kill a process? We are required to give pkill and then signal number and then process name. Not process name, the application name. The application name here is top. Okay. So I will just give top, and you can let me check again. You can see that there is no process running. You can see that I once again it's got killed. So understood that whenever I give pkill, what is the difference? And when I give kill, what is the difference? I can show you here now also. Pkill, I'm giving the DH client process or application name because I ran DH client to get the IP address actually. Okay, so it's running in background. So if I kill, I can rerun this application again to get a different IP address for a different network settings. Okay, so let's move further back to our original topic. We have gone way far. Okay, so we have installed MDADM. Yep, we have installed MDADM. Now let's examine. First of all, we are back to RAID. So in RAID, where we were is we have installed, we have understood the concept. We have installed the MDADM. After the MDADM installation, we are going to look at uh, the steps in creating RAID. So sudo, sorry, we don't need sudo actually. MDADM hyphen examine. So we will examine our dev SDB and then slash dev SDC. So it says that we have MBR master boot record. No such file or directory cannot open SDC. Sorry, it should be dev. Yep. So you can see that its magic partition number is that, and the type is FT. So we are having a Linux auto RAID. Now we'll check the so we'll examine our whatever we have created. No MD superblock detected on dev STP1 and STC1. So that's okay. Now let's start creating the RAID. So command for creating the RAID is mdadm hyphen create, then slash dev slash md0. It's your choice what you wanted to give. md0, then hyphen level equals to mirror hyphen RAID devices. How many RAID devices we want? two RAID devices. And which are all RAID devices are there? Yep, /dev /sdc1, then /dev /sdb1 /dev /sdc1. Okay, so this is the command for creating a RAID. Can't opens dev. Okay, I should have given /dev actually. Yeah, /dev /sdc1. So it's created now. It asks for continue creating array. I have created the array. I have given yes. You can get the statistics also. Proc mdstat. So active RAID. Which devices has got active RAID? SDC1, SDB1. So these are all the two things. And another command to get the details using mdaddm hyphen details dev md0. So this is the detail of that whatever we have created. RAID1 is there. Active RAID is STC1, STB1. These are the blocks. Unused device, none. Sorry, that's previous section. So this is version and RAID level is RAID1. This is the device. RAID devices 2, total devices 2, super block is yes present. Active devices 2, working devices 2, failed devices 0. You can say that when I say failed devices, it means one device is not working. That's called failed device. Spare devices means like if you have added an extra disk and marked that device as a spare, will come back here as a spare disk. So we don't have any spare disk here. So consistency policy rsync, sorry, resync. So that's all. You need not to worry about number, major number, minor number, RAID device, active sync. So that's one thing. Now I can show you that /dev you have SDB1, SDC1, but on the top of that you will have MD0 also. We are able to see some there. Yeah, MD0 here, you can see that. So whenever you are going to write, you are going to write down here. So whenever I'm going to mount, I'm going to mount here. Mount /dev /MD0, and then where I want to mount MNT. I want to mount in MNT. Uh-oh, it's unknown file system, it seems. So maybe I might need to format or do something before using it. So what I need to do now, we can say that this is a plain hard disk came to us, which is behind this MD0 there is a RAID, and which is using two disks SDB1, SDC1. Okay, so now this is a plain hard disk. So now in this plain hard disk we are required to format this, since it complains that unknown file system type. So mkfs, you can make anything, .ext4 also, /dev /md0. It has formatted in ext4 file system. Now if you want to mount, you can mount this drive. You can see that this time it did not throw any error. ls mnt, it will not have anything. It has just only one folder, lost and found. RAID folder. I'm just creating a RAID folder, and I will try to write down something in the inside this first file. Sorry, first file. I have created just two things. MNT RAID folder. I have created a RAID folder inside this RAID drive, RAID partition, whatever MD1 we have created. And inside that, we have created one file as well. That's called first file. Okay, you can see that here. Two things, one folder, and inside one folder, I have created one file. That's it. You can see that also df-h/mnt. Oh,
Sir, you are in mute.
oh, okay. So I was explaining, I was not explaining anything. I was saying that we can unmount this drive also, whatever we have created. And I have pasted a link as well to go through that for the revision purpose and for getting to know if somebody is expecting some more out of whatever we have gone through. You can go through that link. Uh, and I don't follow any specific link. For a reason is like I do Google the topic if anything is there, if I want to send to you guys, and whichever topic explains in a good way and explains or covers more thing, I do follow that topic. So there's no specific blog or website I do follow. So I hope this it's reasonable whatever the information I have give you guys about RAID1. That's all enough for the basics, and then if you are more interested, you can follow up furthermore for failing a drive and marking spares and a spare and rebuild. And if you want to follow more, not more, whatever has been, I have said that failing a drive and marking rebuild, those if you follow July video, that in July videos lectures in some of the RAID, wherever the RAID is there, I still believe that it is there. I have explained to them. So you can follow that as well if you have time. But this is enough for having a basics knowledge of RAID, whatever we have given. Whatever we have covered, that's enough for a RAID. Okay, for interview and for the information actually. If you know this, you can further proceed based on the requirement. So let me stop the recording.